Trigonometric functions of nTheta. Very exciting stuff here. Anytime you have an equation that involves a trig function, you would like to think that it's very straightforward and simple, and you just punch, either look up in the table or just know it, or punch it in the calculator and done. The trouble is, because angles, trigonometric functions and angles are cyclic, whatever. If you graph things this way, angular fashion, you got 0, 90, 180, 270, 360, but you can keep going to 720 to 1080. You just keep going and going and going. But all of the sine values are the same, whether you're talking about an angle between 0 and 90, or 360 and 450, or whatever, however many times around that are within that quadrant. Another way to think of that is if you graph the sine function, etc., 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 you know, sine of 1 is good for this angle, and this angle, and this angle, and. Keep going. So, anytime you have these trig functions, you have to, one of the things that also has to be made clear somehow or other is where you are. So in a case like this, something very simple like this, sine of theta equals 1/2. Well, what would be your natural response to this? What would you think to do first?
Unit circle.
Okay. So, what angle has a sine of 1/2?
30.
Good job, 30 degrees.
Is it on 30 or 60? I get confused.
Okay. Well, which is all fine and good, which is correct. I mean, you can punch in sine of 30 degrees and you'll get 1/2. But that's not the only angle.
Oh, and 360 plus that, so 390.
Exactly. And 150. So yeah. So one of the things that the problem has to specify is, for theta, what are we looking for? And typically what you see is we want all the angles between 0 and 360, including 0, but not including 360, because those would be the same thing. And so one thing that's helpful to remember is the acronym All Students Take Calculus. And what this is useful for is what trig functions are positive in each quadrant. All three of them, sine, cosine, tangent, all three of them are positive here. In quadrant 2, the sine is positive, meaning the other two are negative. Down here, tangent is positive, the other two are negative. And over here, cosine is positive, the other two are negative. So, even between 0 and 360, you've gone through all four quadrants. Taking the sine of some angle, getting a positive number, that could be a quadrant 1 angle or a quadrant 2 angle. So if you find the first one, in this case 30 degrees, say, okay, we took the sine of an angle and got a positive number. So that's quadrant 1. Where else is sine positive? It's quadrant 2. So we take the same reference angle, the same bow tie angle, and do that in quadrant 2, because that is where sine is also positive. And so what's this angle here then?
150.
150. So we have 30 degrees and 150 degrees that are solutions to this equation. Because both of these angles fit the domain and will give you that answer. That's the basic idea. Now, what happens though if we do this? What if we say, want to find out the sine of 3 theta equals 1/2? With the same stipulation as here, that theta be between 0 and 360. Well, you can't just, unfortunately, you can't do, what can't you do? You can't factor out the 3 like that. Unfortunately, you can't divide both sides by 3, cancel that, and have sine theta equals 1/6. We're taking the sine of 3 theta. So we have to work with this as 3 theta, at least for just a minute.
But that wouldn't be 1/6, would it?
No, we wouldn't.
Be 3
Now, so what we can do here, new to the color. What we can do is, since we have to work with 3 theta for a minute, if theta has to be between 0 and 360, what if I multiply this whole, what if I multiply all of this by 3? 3 times 0, don't strain your brain,
0,
okay? 3 times theta
3 theta.
is 3 theta, but then 3 times 360,
It is a big number. So 10, 20,
1080.
1080.
Okay, that's really the tough one. So, so if we want to know what angle will give us a sine of 1/2, but if it's 3 theta, anything between 0 and 1080 is acceptable. So come back to this idea here. We're still going to have a 30-degree angle and a 30-degree angle over here. So 3 theta could be 30 or 150, but since 3 theta can go all the way up to 1080 instead of having to stop at 360, we can go around the circle again. So instead of just 30, we can go all the way to here. And you have to add 360 basically. And instead of going to here and stopping, we can also go around again to here. This is going to get messy. So 360 plus this one, 510. And let's do,
Round.
but we're still only at 510. We're not even halfway to our limit. So we can go around again. So we can go to 30, around and around again. So to get here, we add 360 because we're just going around the circle again. And from here, we can add 360 again. So add 360 again, and we've got 750. And then same thing for over here. We got this angle here, but then we can go around again, which was the 510, and around again. So 360 plus this one, 870. Now what if we went around one more time? Plus 360 would be 1110, and we're outside the range, so
Yeah.
we have to stop here. So we have 6 possible angles that 3 theta could equal. But what are we solving for?
1/2.
What are we solving for?
Oh,
What's the variable?
So if you make
The variable is theta. We need to solve for theta.
3.
So, we got 3 theta could equal any one of these 6. We need theta. We need to divide it by 3. Which means we need to divide all of this by 3. What fun.
So 10,
So we're going to have 6 answers. Theta could be.
10, 5.
And so you go through and divide every single one of these by 3. 10 degrees, 50 degrees,
130.
yep, et cetera, et cetera, et cetera. And 70? Yep. 3 to 50. 290?
Big symbol is 2.
Yeah, 290. So here we have finally solved our problem, or solved the original problem with all 6 valid answers.
Yay!
I know, right? Just what you really wanted to do. So that's the idea. This was example 23.1, 23.2, same concept, except that one. Yeah, but not too bad, relatively speaking. This one they want it in radians. You can tell they want it in radians because it's 0, because theta is between 0 and 2 pi, whereas this one was theta is between 0 and 360. So that's the key you can look for as to whether the problem should be solved in degrees or radians. So in this case, you still want to get it so that your trig function is all by itself on one side of the equation, and put the number on the other side. So you set it up kind of the same way. Let's get started on this one. What angle what reference angle has a tangent of radical 3 over 3? To 30 or 60. And now you have to make me think of it.
Andrew, turn to the office, please. Andrew,
6,
come to the office.
2, 1, radical 3, tangent, that's going to be the 30-degree angle. Okay, so 30 degrees, and it's going to be a positive. Tangent is positive where? Quadrant 1 and 3. So what's a 30-degree angle in quadrant 3?
210.
210. So now that you have your starting angles, we get to go around the circle 4 times. So you're going to do 30 plus 360, plus 360, plus 360, and 210 plus 360, plus 360, plus 360. And then that'll tell you the 8 possible answers that 4 theta could equal, and you have to divide all of them by 4 to get your answer for theta.
Didn't you give like a program or something that did something like that?
Yes, I did. I'd like you to do it a few times first to get the hang of it, and then I will
How many?
teach you how to program the calculator to make it do most of that work for you. At least, this last step.
Okay.
And I'm not just saying that to torture you. I want you to understand what the process, what all is involved before I make the tedium easier for you.
Okay.
So, thanks.